4.6, the quadratic formula. So let's go through this worksheet. So when we're solving quadratic equations, there's lots of ways to solve it. These first three here work sometimes. So they're generally the easiest, but they don't always work. These next two, complete the square, which we did last time in quadratic formula, which we're doing this time, these two always work. So if you have a problem and you can't factor it, you have to do one of these two. Factoring is generally the easiest way though, so when you can, you want to try to factor. So let's look at this first one. We're going to solve this equation. Now, if you notice this one, the middle term is even, and the first term has a coefficient of 1. That's usually the case, so the best way to do that is by combining the square. When the middle term is even, the coefficient of the first one is 1, it's a really good way to decompress the square. But this last thing is quadratic formula, so we're going to do a quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So in here, we got to know what each letter is. So a is the 1, coefficient of the leading coefficient, or the coefficient for x squared. B is 4, the coefficient of the linear term. And then c is the coefficient of the constant, which is 7. Notice there's no x's here. It's the coefficient of the term, not the actual. You don't actually put the variable values there. So now let's sub this in. So x equals negative 4 plus or minus 4 squared minus 4ac all over 2 times a, which is 1. Now let's simplify this. This is 6, that's an ugly 4. 16 minus, I didn't plug in a and c. A is 1 and c is 7. Sorry about that. That's 28. So I get negative 4 plus or minus negative 12 over 2. I do have to reduce negative 12. It's a negative, so it's I rad 12. I do got to break down 12, though. So 12 is 1 and 2 and 6. I have to start small. That is 2 and 3. So that's 12 prime factored. You have a pair of 2's here. They come on the outside. And rad 3 stays on the inside. So we have this. Negative 4 plus or minus 2i, therefore the 2, rad 3 all over 2. That's a good answer. If you want, you can simplify it a little bit further. Everything divide. Let me make this a little nicer. There we go. Everything divides by 2. A lot of people just cancel out the 2's right here. That's not that, you can't do that. What you gotta do is factor out 2 from the top. And now these two cancel. So your answer will be negative 2 plus or minus I rad 3. So you have to be able to cancel from both terms on top, not just the one of them. So this will be my full and complete answer. Next one. So this one has, so the next one, if you notice, the coefficient of A is 3, B is 1, and C is 1. Now, since the middle term is an odd number, and the A is also not 1, probably not the best to do complete the square. You want to stay as far away from the possible. You want to factor if you possibly can. This is a good one to do quadratic formula from the very start. So we're going to do that. X equals negative b, so negative 1 plus or minus 1 squared minus 4 times a times c, 3 and 1, all over 2a. This is 1 minus 12, so I get x equals negative 1 plus or minus square root of negative 11 over 6. I pull the negative out, I get x equals negative 1 plus or minus I rad 11 all over 6. Move on to the next one. The one right here, that's a good one to factor. It looks like a factor. Let's actually factor first. 2 things that multiply get 7, but add to 2 things that multiply get more negative 14, but add to get negative 5. That would be 7 and 2. Negative 7 and positive 2. Get you this guy, so it would be n minus 7, n plus 2 equals 0. Split it, n would equal 7 and negative 2. That's by far the easiest way to do this, but let's practice our quadratic formula. So a would be 1. Let me erase some of this. A would be 1, B would be negative 5, and C would be negative 14. So plugging the quadratic formula, I would get negative negative 5 plus or minus b squared negative 5 squared minus 4 times 1 times c, negative 14, all over 2 times a, which is 1. So over here, double negative gives me a positive 5. Negative 5 squared is just positive 25. 4 times 14 is 56, so plus 56 because double negative again. So I get 5 plus or minus 2, 6 into 1, 81. square root. Simplify a little bit more. 5 plus or minus 9 over 2. Now, since it's 2 of them, I gotta split it up. 5 plus 9 over 2 should be 14 over 2, which will give us the 7 we got before. And 5 minus 9 over 2, which will give us negative 4 over 2, which will give us negative 2 we got before. So again, it works both ways, using the quadratic formula or just factoring. Factoring by far most times is easier. And the same thing with this one. If I want to take this factor, they will have a k in there. So it'll be 7k plus 9 equals 0. K would equal 0 and negative 7 ninths. But we're going to practice quadratic formula, so we'll do that. A is 7, B is 9, I don't see a C, so that means it's 0. So if you have a quadratic formula, you're using it this way. Anytime you don't see the term we need, it's 0. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Well, in this case, I get 81 minus 0, so I just get negative 9 plus or minus square root of 81 over 14. That's 9. So I would get x equals negative 9 plus 9 over 14, and x equals negative 9 minus 9 over 14. This will get me 0, so just 0. This is going to be negative 18 over 14, or if you reduce it, divide by 2, negative 9 over 7, which we got before. So again, lots of ways to solve quadratics. Easy way for most people is set equal to 0, and then either factor or use a quadratic formula. Well, what's the next one? The discriminant. Discriminant, I will always give you the formula. That's this guy. All you have to know is what does discriminant mean. Well, if you notice, that's the thing underneath the radical. That's the thing that's the radical in the quadratic formula. That is, looking for it right over here. Somewhere over here. Let's go back to this guy. It's this thing. That's the discriminant. So that lets you know, hey, if I take the square root of that, and the discriminant equals 0, I'm only going to get one real solution. If it's a positive, I get a plus and minus like here. So I get 2 real solutions. So if it's greater than 0, it's positive, 2 real. And if it's negative, is the thing underneath the radical is a negative? Well, then you get an I, right? So it means 2 imaginary, or no real, also known as 2 imaginary. So that's all we have to do here. Just see how many real solutions we have. So my A is this, my B is this, and my C is this. Just plug into the formula, and I get negative 3 squared minus 4 times 9 times 2. So I get 9 minus 36 times 2 is 72. So I'm going to get negative 63. That's a negative, so I get 0 real solutions. Next one, ABC. B squared minus 4AC. So I get 6 squared minus 4 times 9 times 1. I get 36 minus 36, which is 0. So 0 means it just goes away. So you have 1 real solution. You get the 1 real answer. So my guess is this one would be the 2 real. Let's try it. ABC. B squared minus 4AC. So negative 8 squared minus 4 times 9 times negative 2. So this is 64. Remember, you square the negative and it becomes positive. These two things are two negatives here, so you get a positive. Positive 72. I don't care what it equals, it's positive, so I get 2 real. And there's that. Match your graph with the correct discriminant. So remember, when the discriminant is greater than 0, you have 2 real solutions. Real solutions in graphs, it's just x-intercepts. That's all it is. Just x-intercepts. Roots, x-intercepts, all that. So that means that this is C. Probably should put the C right here, which is where it's supposed to be. There you go, C. 2 real. Equal to 0, that's 1 real. Right, so 1 x-intercept, that's this guy right there. So this would be B. So that's what we call a double root. It's the same answer twice. Less than 0 is 0 real. So it means all imaginary, so you have 0 x-intercepts. Remember, real roots are just x-intercepts, so that'll be A. Like that. Next one, the function is defined by f of x equals x squared. So this one, the function f is defined by f of x equals x squared minus 2x plus k. Find the values of k for which f of x has no real roots. So this is the key to the problem. No real roots. As we talked about, discriminant means it's less than 0. So that's what we got to do here. We got to find the discriminant, b squared minus 4ac, and set it less than 0. So let's find those values. What's a? Coefficient of x squared, so 1. B, coefficient of linear term, so negative 2. And c is a constant term, which in this case is k. Let's plug it all in. So I get negative 2 squared minus 4 times 1 times k is less than 0. So let's do some math. 4 minus 4k is less than 0. Let's solve for k here. So subtract 4 from both sides. Negative 4k is less than negative 4. So less than sign. Divide by negative 4. When you divide by negative, you have to flip the inequality. So you get k is greater than 1. And that's the answer there. If when k is greater than 1, then this thing has no row roots. So let's do this next in the same way. The function f is defined by this, where find the values of b for which f of x has one row root, a double root. So that means the discriminant equals 0. So same idea, but now discriminant equals 0, because that's what one row root means. So find our a, b, and c again. A is 2, b is b, negative b actually, and c is 9. So plug it in. Negative b squared, it's a little weird, minus 4 times 2 times 9 is equal to 0. Negative b squared and times squared negative becomes positive, so it becomes b squared minus 8 times 7 is 72 equals 0. Move 72 over. B squared equals 72. Square root both sides. B equals the square root of 72 plus or minus actually 72, not 92. I do have to break that down. So 72, that's 2 times 36. And I'm going to stop there. And the square root of 36 is 6. So it's going to be 6 rad 2. So B equals plus or minus 6 rad 2. There we go. That's the video.